In this video, we're going to add and subtract square roots. So simplify the following, assuming x is greater than 0, y is greater than 0, and z is greater than 0. You'll notice that x to the fourth, y to the sixth, and z to the second are all the same. So our goal here is to try and get the two numbers here inside the square root to be the same so we can actually add them together. I'm going to start by breaking down, let's start by writing down the square, perfect square. So 4, 9, 16, 25, 36, 49, 64, 81. And we'll start by trying to divide 50 by 4. That doesn't work. 50 by 9, that doesn't work. 50 by 16, that doesn't work. 50 by 25, that works. So we're going to have root 25 times root 2, x to the fourth, y to the sixth, z to the second, plus, let's go with this root 200 piece. We're going to try and divide by 4. That does work, so we're going to have root 4. And then we'll have times root 50, x to the fourth, y to the sixth, z to the second. Now you should be able to see that we could have actually just combined those two together had I gone a different route, but we're down this rabbit hole already, so we're just going to keep going. Root of 25 is 5. So we have 5 root 2 x to the fourth, y to the sixth, z to the second, plus 2. And then I'm going to start dividing by root 50 by perfect squares, but we already did that once. We know that 25 can be divided by 50. Sorry, 50 can be divided by 25. So we end up with this being times root 25. And then inside here we have root 2, x to the fourth, y to the sixth, z to the second. Evaluate this root 25, and we have 5 root 2, x to the fourth, y to the sixth, z to the second, plus, that'd be 5, but I'm taking it times 2, so I end up with 10. So this is root of 25, which is 5, times 2, which is 10. Root 2, x to the fourth, y to the sixth, z to the second. Now I have the same base for each square root. Because of the same base, I can actually just add there's 5 of them here and 10 of them there. That's a total of 15. Root 2 x to the fourth, y to the sixth, z to the second. And then I can simplify the variables. So x to the fourth, we know that x squared is a perfect square. And we can take 4 divided by 2 to figure out what's on the outside. So we end up with 15. 4 divided by 2 would be 2, so I end up with 15x squared. We can take y to the sixth, divide it by 2, and that'd be y cubed on the outside. And then z squared, if I take the square root of that, I just get z on the outside. So the only thing left on the inside is root 2. And that's how you add and subtract square roots.